So let's start. I had this in front of me when I made up your test on the weekend. Your test is not going to be this long, but it's going to be fairly similar with a couple of exceptions. I added a couple of things as well. What's the degree of a quadratic? Quadratic, degree 2. What's the degree of a cubic? What's the degree of a cubic? 3. What's the degree of a linear? 1. What's the degree of a constant function? 0. What's the degree of a trig function? No, it's not a polynomial. Polynomial functions are the only things where we talk about degree. What's the degree of this function here? I have to identify. It's not a linear. It's not a quadratic. It's not a constant. What is it? It's a cubic. Degree 3. What else could I ask you? How many turning points does this function have? 2. What's the maximum number of possible roots this can have? I'll give you a hint. What's the degree? What's the maximum number of roots? 3. It's one of the reasons degree is handy. An x cubed equation will have at most 3. Now this one has 1, 2. Or if I slid this lower, you might only have 1. For a cubic, you can have 1 or 2 or 3. Not 4, not 0. Those might be some kinds of questions I could ask as well. Number 3, number of turning points for this? None. What's the degree of this polynomial function? 1. What's the degree of this? Well, if I FOIL this out, I will get an x cubed degree 3. Number 6 was sneaky. What's the leading coefficient? It's not 4. And the reason is they did not simplify this polynomial. This is really 4x plus x. What is 4x plus 1x? This is really 5x plus, and what's 2 to the third power? 2 cubed. Whose phone was that? Oscar? Thank you. Put your phone away. You got caught there. 2 cubed is 8. This is really the simplest form equation. What's the leading coefficient? 5, not 4. Leading coefficient, though, is the number in front of the biggest degree term, once you've simplified. How many turning points in this? Now, you could graph this, but wait a minute. What kind of a graph is this one? You know what? It looks like that or like that. How many turning points does it have? Just 1. What's the fancy term for that turning point? It begins with the letter V. Vertex. And you can find it by using the maximum and minimum functions of your graphing calculators. Number 8 says determine the equation of this polynomial function. Okay, first thing, this is not a parabola. Come on. Give me a second here. Okay, let's try this again. This is not a parabola, so I would cross that out, I would cross that out. Okay? Now there's 2 ways to do the next part. You could either look at the y-intercept. Mackenzie, we said the y-intercept was always the constant term. Here it's a plus 0, because there is no constant term. No constant term means a 0. What's the y-intercept here, Mackenzie? What's the y-intercept? How high? You know what? It's got to be this one. The other way you could do this is to look at whether the x cubed is negative or positive. A negative x cubed will do that, just like a negative line will do that. A positive x cubed will do that, just like a positive slope will do that. There is going to be a question, something like this on your test, where I give you a graph and I say, hey, tell me the equation. Number 9, why can I cross out C and D right away? Yeah, it's a parabola. And in fact, the parabola, we're familiar enough. Is that a negative or a positive parabola? You know what? It's got to be A. But also, notice you could have looked at the y-intercept, the constant term, which is negative 1, and you could have said it's got to be that there. I got 2 options. Number 10, fill in the blank. This quadrant or this curve extends from quadrant. So the quadrants go like this. 1 is the positive, positive, and then it goes counterclockwise. That's 2, that's 3, That's 4. I think I did give you one question like this on your test where I said, tell me this curve goes from quadrant what to quadrant what. By the way, this one goes from quadrant 2 to quadrant 4. B. Determine the equation of the linear regression function. Okay, this is going to be straight graphing calculator. Menu, stat, 2, 5, 8, 10, 12. Need to move over just a tiny bit so I can see the whole screen. Let's go over here. 14, 17, 20. 135, 120, 115, 102, 92, 85, 78, 64. Graph. Hey, it is linear. That's nice. Calculate. Which one of these is a linear one? Just the x. That's like x to the 1. So as a linear equation in the form y equals ax plus b with a 99 r value, which means we're pretty good, the equation is going to look like this. Y equals ax plus b. Y equals, what's a? Negative 3.9. X plus, what's b? 141.8. Oh, they were a little sneaky. They changed the order, but it is C. Yes? Now, I might also ask you to do something with that equation. In other words, now as a part B, I might say, okay, so if x is 13, what's y? Well, somewhere between 12 and 14, I could use my graphing calculator. I have one like that later. What kind of relationship might there be? You know what? It's a quadratic, isn't it? It's definitely not linear. Now, the other thing it could be part of a sine function. We'd need more data. But since I told you those 4 options, I didn't give you sinusoidal to pick, we'll assume it's a quadratic. Number 13, they gave me an equation. D is the horizontal distance. H is the height in meters. It's a bit tricky because it's meters and meters. I'm going to have to read really carefully. It says find the height. You know what? This is a y-cal. Find the height. This is my x value. Okay, I'm going to type this into my graphing calculator. Y equals negative 0.048 bracket x squared minus 20.7 x minus 26.28 close bracket. View window. Well, this is a y value, and the y values that they give me go up to 6.8. So at least for my y values, and I got to go 10 meters horizontally. You know what? I'm going to go with this view window from 0 to 12. That'll give me 10 meters horizontally. And from 0 to a little bit bigger than 6.87, I'll go with 0 to 8. Okay, that looks good. This is a y-cal, G-solve, y-cal when x is 10. 6.4 meters. Number 14, do a quadratic regression. Okay. Menu, stat, delete, 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 or delete, arrow sideways, delete all, delete all. Okay. So 10, 11, 12, 13, 14, 15, 16, 17, 156, 135, 128, 123, 134, 147, 170, 203. Is this a parabola? Does this look like a... Hey, that looks like a... Again, could be part of a sine function as well, but we're going to assume it's a parabola because they said quadratic. Calculate x squared, and I have y equals... Well, the pattern is ax squared plus bx plus c, and then it says a is 4.21 x squared. Is that enough that I can quit? Not quite. Cancel, cancel. Minus 106 point, actually minus 107. X, nope, doesn't help. Plus 803.5. A. Cubic regression. Same dealio. Exit. Exit. Delete all. Delete all. Alrighty. Cubic regression. 2, 4, 7, 10, 12, 13, 17, 19. 135, 120, 105, 102, 99, 88, 78, 47. Graph. Okay, that looks sort of like a cubic-y thingy. Calculate. X cubed. You'll notice my r squared, still pretty good. Now here, if I go down arrow, the pattern is ax cubed plus bx squared plus cx plus d. So it's going to be y equals ax cubed plus bx squared plus cx plus d. Where a is, careful, that's b. I got to go up arrow. A is negative 0.05 x cubed. You know what? That's wrong and that's wrong. Plus 1.5 x squared. Didn't help. Minus 16.1 x. Hey, that narrows it down. It's b, and then plus 162.5 right there. So b. Number 16, use quadratic regression. Okay. Exit, exit, exit. Delete all. Delete all. 0, 2, 3, 3, 4, 6, 7, 7. 17.5, 30.3, 30.8, 31.5, 25, 8.3, negative 7.6. Negative 9.1. And it says use quadratic regression. Graph. Looks like a parabola. Now it wants me to find the value of y when x equals 5. So I'm going to go copy, execute. Oh. Make that a bit bigger. There we go. Menu, graph. Hey, there it is. I wonder if it's already got a good window. Oh, forgot to turn the stupid graph on. Turn it on. Draw. Does it work already when x equals 5? G-solve. Do a y calculation when x equals 5. Oh, it worked already. Looks like x equals 19.1. C. So there's an example of a question, Oscar, where I'm making you find the equation and then do some kind of interpolate. Find a value with a value. Choose the best estimate for 120 degrees in radians. 120 degrees times pi divided by 180. .1 radians. Choose the best estimate for the central angle in degrees. A little more than 270. How about B, 273? Choose the best estimate for the central angle in radians. Well, this would be pi. This is bigger than 1 pi. So B can't be right. If B was right, it would be down there somewhere, just past pi. 5 over 4, is that bigger than 1 pi as well? That's too big. 5 over 6, that's really close to 1 pi. What about 5 twelfths? Well, if this was 12 twelfths, then this would be 6 twelfths, and 5 twelfths would be there, which is nowhere close to what they gave me. You know what? The correct best estimate here is 5 pi by 6, just shy of 1 full radian. Sorry, just shy of pi radians. What's the range of this? Has an amplitude of 1, has a midline of 1. So I hold my hand here, 1. What's the amplitude? Also 1. So 1 up, 2, 1 down, 0, between 0 and 2. Absolutely is going to be a couple of questions like that on your test. Holding the hand out, smacking the person beside you in the face, optional but helpful. What's the midline? It's going to be halfway between -2 and +6. I think the midline is going to be right there at y equals 2. How can you do that mathematically? If you go 6 plus -2, 4, divide by 2, 2. But I usually do this because I can visualize it like that, Chelsea. Turn the page. What's the amplitude? 6, -2. The total distance is 8. The amplitude is 4, half of 8, because it goes 4 up, 4 down. That's why you have a total distance of 8. 23, find the period. Okay, period is going to be, well, from peak to peak, which is 1, 2, 3, 4, 5, 6, 7. I think the period is 8. By the way, if the period was 8, b would be 2 pi over 8. That would be the number in front of the x. Range 5, 1, a. Select the function with the greatest amplitude, b. Find the midline, d, y equals -1. 27, the following data set is sinusoidal. Okay. Menu, stat, delete all, -3, -2, -1, 0, 1, 2, 3, and then 1, 1.7, 2, 1.7, 1.3, 0. Graph. Oh, that does look like part of a sine function. Calculate. Said make sure it's sinusoidal, which on this one is F5. Okay. The equation is y equals 0.996. I bet you the actual amplitude is 1, but 0.996 sine 0.784 x plus 2.354 bracket plus 0.9, probably plus 1 again. But there's my equation. Copy. Execute. Menu. Go into the graph menu. Turn that graph back on. And it wants me to find when x is 12. So I better go from -4 to 14 past 12. I'm going to leave the rest as is. I'm going to hope it works. Let's see. Oh, that looks pretty good. G-solve. A y calculation when x is 12. 0.28? 0.3, I guess. That's a little rough, but okay. Sure, 0.3. Is that right? 27? B? Anybody? You're all focused? Find the equation of the sinusoidal regression for this. Menu, stat, arrow sideways, delete all. Delete all. 0, 5, 10, 15, 20, 25, 30. 120, 138, 122, 105, 121, 140, 125. Calc or graph. Hey, that looks like a trig function. Calc. Sinusoidal. So here it is. Y equals 17.1. Y equals 17.1.1. Sine. You know what? Why can I quit right there? Mark? Yeah, you know what? Sorry, didn't mean to cross that one off. It's got to be B. But for what it's worth, it would be then bracket 0.31x, because it's sine B, there's B, x, plus C, negative 0.05, close bracket, plus 121.9. Or 122. Short answer. What's the degree of this? 0. How many x-intercepts and y-intercepts can a cubic have? Okay. A cubic can have up to 3 x-intercepts. Has to have at least 1. How many y-intercepts? Only 1. But it will have 1 somewhere because it's got a range of all reals. How many x-intercepts might a polynomial 2 degree have? Well, that's a parabola. You can have 3 situations. You can have 2, or you can have 1, or you can have none. 0, 1, or 2. Can't have 3. Find the equation of the quadratic regression for the data. I am going to give you a quadratic regression or some kind of regression questions. Are you guys okay on stuff like number 4? So I'm going to skip that. I'll let you try it on your own. Okay? 5, find a cubic regression. Same idea, but pick the x cubed. Do you want to talk? I like number 6, like number 6, like number 6.
Number 6 give me on the test.
This or backwards. I'm either going to give you the amplitude and the midline and say, tell me the range. Or Taylor, I'm going to give you the range and the amplitude and say, tell me the midline. Or I'm going to give you the range, Pam, and the midline and say, tell me the amplitude. Okay? So here, Pamela, my joy, what's the midline in number 6? So hold your non-writing hand, for you, your left hand, is that right? Out. -2 high, like that. What's the amplitude? So from -2, go up 9. Where do you end up? Can you do the math in your head? How high will you end up? 7. Back to -2. Go down 9. Where will you end up? The range is going to be, the lowest you'll get is -11. The highest you'll get is 7. And it's a range y between those, less than or less than. Okay. Number 7 says use sinusoidal regression to determine the missing value to the nearest tenth. Okay. Clear that. Clear that. 0, 1, 2, 3, 4, 5, 6. 15.5, 13.6, 20, 27.7, 28.3, 21.2, 14. Graph. Looks like it could be a parabola or sine curve. Calculate. It does say use sinusoidal regression, so we'll do it as a sine curve. Now they want me to find what the value is when it's 7. So I'm going to go copy, paste, turn the graph on, view window. Well, when x is 7, I'll go a bit past to 8. I'll take a gamble. I'm going to leave these because my software usually actually picks okay stuff there. So I'm just going to go draw. Yeah, that fits. G-solve, a y calculation when x is 7, 14.7. Brianna's position on a Ferris wheel can be modeled by this function here. Woohoo! Where t represents the time in minutes. Okay, I'm going to carefully type this into my calculator. Exit. Delete this. 15.4 sine bracket. 2.3 x, because I don't use t. Take away 1.4, close bracket, plus 17.2. There's my equation. View window. Time starts at 0. 30 seconds, I'll go to 32 seconds. Scale, I don't know. I'll go by 5s. Y min, 0 for a Ferris wheel. What's the maximum? Brianna, what's the amplitude of this trig function? What's the midline? So the highest it's going to get is if I add those two together. If I add those two together, I get 30-something. You know what? I'm going to go up to 40. That should give me some breathing room. And I'll go up by 5s here too. Oh, there's your Ferris wheel. You go up, you go down. You go up, you go down. You go fairly quickly, apparently. This is pretty intense Ferris wheel. Okay? Oh, you know why? Because this has the time in what? Can you read that to me, Brianna? And this is the time in what? Seconds. So you know what? 30 seconds. I'll go 1 minute. 1 minute is how many seconds? But this is the time in minutes. Sorry, 30 seconds is what fraction of a minute? This is half a minute. I need to change my view window. Instead of going from 0 to 32 minutes, I want to go from 0 to 1 minute because half of that will be 30 seconds. Okay, that's better. You get on, you go up. How high are you when you get on? G-solve, y-cal at time 0. You're 2.02 meters off the ground. Then, G-solve, arrow sideways, y-cal after 30 seconds. Sorry, after 0.5 minutes, which is 30 seconds, you are 13.4 meters off the ground. How much higher are you than when you started? 13.4, take away 2.02. You're about 11.4 meters higher. I'm not going to give you one quite that lengthy, but I would have no problem giving you an equation and Sterling ask you to apply it. Okay? Problems, number 1. It says describe this graph by determining its range. Okay? Negative 2.5 to positive 0.5. The equation of its midline, y equals, well, it's going to be halfway between negative 2.5 and positive 0.5. It's going to halfway between, you know what, I'm pretty sure if I want to find it mathematically, I can go negative 2.5 plus 0.5 divided by 2. I think it's going to be right at negative 1. I think my midline is right here. Yes? 1, 2, 3 squares above, 1, 2, 3 squares below. Yep. Amplitude. Well, the total distance is from 2.5 to 0.53. Amplitude is 1.5, I think. Pretty sure. Period. Well, from here to here is one wave. 1, 2, 3, 4, 5, 6, 7, 8 squares. What's one square worth? 30 degrees? I think it's 240 degrees. That's kind of a yucky one. Number 2. Amplitude. 6. Midline. Y equals negative 4. Range. Negative 4, Pam. Amplitude. 6 up. Negative 4. 6 down. Negative 10, less than or equal to y, less than or equal to 2. And the last thing it wants is the period. That's going to be 2 pi over 8. Or pi over 4. 2 pi over b, the number in front of the x. And in front of the x, there's an 8. Which of the following graphs represents a polynomial function? No, no, no. A, D, and E. Because A is a cubic, D is a linear, E is a quadratic. I like that question, I like that question, I like that question.
Question you made on the test?
Something like it. Nearly done. Number 4, 5, and following, these I stole directly from very similar questions to the test. So, determine the maximum number of x-intercepts. For a quadratic, maximum is 2. For a cubic, maximum is 3. For this is an x squared, 2, 1. What's the y-intercept? It's the constant term. Oh, don't put that there. It's the constant term 3. It's the constant term 4. It's the constant term. If I FOIL this out, this is x squared minus 3x. There is no constant term. 0 and 1. How many turning points? A parabola has 1. X cubed. This one I'll have to graph. X cubed minus x plus 4. And when I'm not sure what these look like, I go view window standard is kind of my default. Oh, 1, 2 turning points. Let's try instead of x cubed minus 3x, it's x squared. Quadratic, 1 turning point. Linear, none. Domain, all reals. All reals, all reals. All of these graphs go that way forever. Range, I got to graph this puppy. X squared plus 2x plus 3. Put it face down in the appropriate block, kiddo. Draw, G-solve, minimum. The range, everything above or touching 2. Y greater than or equal to 2. Range of a cubic is all reals, and range of a linear is all reals. I just got to do this second quadratic. Y equals x squared plus, minus 3x. G-solve. Minimum. Everything above negative 2.25. Y greater than or touching negative 2.25. Nearly done. Cost of a taxi ride is given in the table below. Create a scatter plot. Okay, lots of typing, but I can do this. Menu, stat, delete all, delete all. 37.85, 2.12, 86.37. This is lots of typing. On the test, I kept them shorter. 21.07, 12.12, 27.62, 70.49, 8.4, $152, Mr. Dueck, and 77 cents. 10.89, 37.76, 64.16, 40.93. That, what happened there? Something go wonky here, Mr. Dueck? I'm missing some terms here. Okay, 100. Stuff's not matching. 30. Okay, 56. 20.07, 40.993. Good gosh. 26.55. 52.09. Okay, I got to check these points. 22 went with that. 12 went with that. 21 went with 1906. 30, yeah. 86. 84. Okay, I think I'm good. Whew. Graph. That looks linear. Calculate. Linear. First of all, describe what you observe. I'm pretty sure this is linear. Determine the regression line. Okay, equals. I'll use C for cost. instead of y. And it's going to be 1.71. Instead of x, I'll use d for distance, plus $5.13, plus 5.13. What's the cost of a 40-kilometer trip? So now I can go copy, execute, menu, draw, select, view window. From 0 to 50, since they're going to do a 40-kilometer trip. G-solve. A y calculation when x is 40. $73.57. The starting amount for any taxi trip, that's on the next page for some reason. Well, the starting amount is going to be G-solve y calculation when x is 0. Looks like you pay $5.13 just to flag the cab down. And if you've taken a taxi cab, none of them start at 0, right? Just for stopping, you're paying a minimum price. You guys good? I know I'm talking a lot. Stay focused a little bit longer. Scatter plot here. Okay. Menu. Option 2. Delete. Delete. 1, 3, 5, 7, 9, 11. 184,000. 160,000. 151,000. 157,000. 170,000. 195,000. Hey, that does look parabolic or quadratic. So it says create a scatter plot. Something like that. Find the quadratic regression equation. Calc, quadratic. It's going to be equals, instead of y, I'm going to use n for number of males. N equals 1486.6. Instead of x, I'm going to use y for years squared. Minus 16,539. Minus 16,539 y. Plus 197,197,874. Plus 197,874. Hope that's right. Copy. Paste. Graph. Activate. Use this to estimate in 1996, which is 6 years after 1990. Let's see if it's already on here. It might be G-solve when x is 6. What's the y value? There you go. 152,156. People. How many more am I doing here? Whew. Oh, nearly there. Females who entered a trade program in Canada. And apparently this is going to be a cubic regression. I have a feeling this is actually going to be pretty lousy data. One, 5, 7, 9, 13, 15, 17, 8,200, 11,400, 13,300, 15,600, 24,200, 28,700, 38,000. Graph. Might be cubic. I don't know. Calc. It does say try it with an x cubed. Oh, that's actually a pretty good R value. Okay. Females equals 7.18. Y for years cubed plus negative 80.6 y squared plus 1,091 y plus 7,147 cubed, squared, y, nothing, constant term. There you go. Use this to estimate the year in which the number of females was 19,000. Copy. Menu, graph, view window. So, you know what? I think this might work if I just go, no, forgot to turn the stupid graph on. Draw. G-solve. Now this time, this is an X calculation. When we have 19,000 people, apparently in year 11, which must be 2001 since we're starting in 1990. Thanks for your patience, folks. Nearly done. More trig. So these are or versions of this are also going to be on your test. Convert the following degree measures to radians. So to go from degrees to radians, you take the degrees, you times by pi, divide by 180. 16 times pi divided by 180. 16 times pi divided by 180. Point, how many decimal places does it say? 1 decimal place? Okay. 0.3. That's a little rounded off, but okay. 115 times pi divided by 180. 2 radians. Hey, 230 is twice as big as 115. I bet you the answer is 4 radians, but let's find out. Four radians. 666 times pi divided by 180. 11.6 radians. How do I go from radians to degrees? I take the radians and I times it by 180 degrees and divide by pi. So this is going to be 8.5 times 180 divided by pi. 487 degrees. .24 radians. 7.24 times 180 divided by pi. 415 degrees. 0.8 times 180 divided by pi. 46 degrees. 12 times 180 divided by pi. 688 technically degrees, but I'll take 687. 688 degrees. Graph sine on the grid below. Sine is an amplitude of 1. So it goes as high as 1, as low as -1. Has a period of 2 pi, which means that'll be halfway, that'll be halfway to halfway, that'll be halfway to halfway. And sine starts in the middle and goes up to the top, to the middle, to the bottom, to the middle. There's a sine graph. If I was graphing this for 2 marks, I'd probably give you a half mark for starting in the right place, a half mark for getting the amplitudes right, half mark for getting the period right, and then a half mark for the shape going up. Graph cosine of x. Okay. It's also got an amplitude of 1, which means it goes 1 and -1 high. It also has a period of 2 pi, which means I can cut it in half and cut it in half. Cosine starts up high, then goes to the middle, then goes low, then goes to the middle, then goes up high. Cosine look like that, except it should really go right through there, sorry. I like number 5, I like number 5, I like number 5. Number 5, I'm going to be giving you 3 or 4 trig equations and saying fill in this chart. Okay. Amplitude is the easiest one. I usually do that first. 3, 2, 2, 1. Then I do range. Sorry, then I do midline. Y equals -1. Y equals -2.5. Y equals 0. Y equals 0. Why do I do those first? Because now I can get the range. The midline is -1, right down there. Amplitude is 3 up from there, 3 down from there. 3 up from -1, your highest value is 2. 3 down from -1, your lowest value is -4, less than or equal to y, less than or equal to 2. -2.5, 2 up, -0.5. 2 down, -4.5. Midline is 0, amplitude 2, -2. It goes from -2, less than or equal to y, less than or equal to 2. Here, amplitude is 1, midline is 0. It goes from -1, less than or equal to y, less than or equal to 1. Ranges between 0 and 1. Period. 2 pi over the number in front of the x. What is the number in front of the x here? 1. So you know what? Just 2 pi. Here, b, the period will be 2 pi over 2, or just plain old pi. Here, it's going to be 2 pi again. Here, it's going to be 2 pi over 4, or pi by 2, because 2 over 4 is a half. Ah! Nothing? Little amplitude in my voice there. Amplitude 1, amplitude 3. Midline y equals 2. Midline y equals 4. Back to C, midline 2 high, 1 up from there, 3, 1 down from there, 1 less than or equal to y, less than or equal to 3. And by the way, I think this is supposed to be D followed by E, isn't it? Because I think I had a C already, didn't I?
No, it's supposed to be C and D.
Okay, C and D. I knew something was wonky there. Midline is 4, amplitude 3, so it goes as high as 7, as low as 1. Period. 2 pi over the number in front of the x. Hey, there's an invisible 1. Period. 2 pi over 2, or just plain old pi. Last one. Woohoo! During a physics experiment, Carol held down a weight to a spring and then released the weight. The height of the... You know what? If you pull down on a spring with a big weight and it bounces, I think that'll end up drawing out a sinusoidal function. So, let's do some regression. Let's regress, shall we, Brianna? I've been regressing all year. No, I mean, okay, mathematically. Delete. Delete. Didn't delete. Let's try that again. Delete. Okay. 0, 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, 3, 9, 15, 9, 3, 9, 15, 9, 3. Graph. That looks like a trig function. Calculate the sinusoidal regression. Okay. Y equals 6. How about H equals 6 sine bracket 3.14159. Oh, what do you think 3.14159 is really? You know what? I bet you this is a period of pi. Right, Jordan? Give me an elbow for me. Is you that far gone? I think you were. Pi or 3.14159. You can write that too, but I happen to notice that's pi. T instead of x. And then plus c minus 1.57, which actually is pi by 2, but that's okay. Plus 9. There's my graph. There's my equation. For 2 marks, I would give you a half mark for the amplitude, a half mark for the period, a half mark for that, and a half mark for the midline. How high? Okay, let's copy, paste. You guys with me okay? A little focus here, or ceasefire. Don't be regressing to the mean. After 0.7, G solve. Y calculation after 0.75. It's going to be 13.2 meters. How high will it be after 5.3 seconds? G solve. Y calculation 5.3. Uh-oh, my graph's not big enough because I didn't change my view window. Oh, only goes to 4.6. How about I go to 6? Graph. G solve. Arrow sideways. Y calculation. X is 5.3. 12.5. There it is. One more thing. The only other thing that's going to be on your test that I didn't put on this review, I did, where is it, Mr. Dueck? I gave you, I think, 4 questions where I'm asking you to draw some rotation angles, but in radians. So something like number 7 from the first quiz. Okay?